Hi, I am Raman Ishala from Cisco Systems. I'm going to show a live demo of deploying UCS and operating system automatically with Ansible for a software-defined storage solution. So I'll be pausing the video because the demo runs for an hour. As part of this demo, I'll be walking through a multi-pod UCS SDS deployment, the automation workflow, the hardware and software requirements, and let's summarize in the end with the timelines of installation. The architecture consists of a pair of Nexus switches and two UCS domains. The repository VM and the SDS UI nodes are pre-configured along with the Nexus switches. Anything below and including the F5s are automatically installed in the process. Okay. The workflow consists of configuring the uplink ports, the port channels, followed by discovering the hardware, and then associating the service profiles, and then the OS will be installed on each node with any other packages for SDS. For Cisco UCS, you need on the repository VM, the UCSM SDK and UCSM Ansible. For Linux Kickstart, you create the boot ISO files and pre-run a script to create Kickstart files for all your nodes. I have provided few commands for configuring the Ansible and preparing the OS install below. Okay, let's jump into the demo now. So I'm using UCS for Ansible here. I have created for simplicity two templates, SDS1 and SDS2. Let's kick off both of them. Let's do for SDS2 as well. And let's see in the UCS now. So this is pod 1. In the pod 1, I already find chassis 1 and chassis 2 discovered. In pod 2, not yet. Okay, now I find chassis 1 here, and also chassis 2 with some SIOCs. Okay, I find the network ports are configured, and in domain 1 I do find servers coming up. Okay, after a brief pause, I find that the discovery is done. The VNIC templates are getting created right now. Let's see the other job as well. Okay, it is adding the chassis profiles now. Let's see in the UCS. The servers are in unassociated state, and the VNIC templates are created here, and the port channels are also up. So what we find is the service profile templates are getting associated now. I may have to pause the video for a few minutes. Okay, now the service profile templates are also complete. Association is complete. Let me check in the other one. It's okay, here also it is done. So they changed 45, failed 0, and the elapsed time is around 44 minutes. So for both the pods put together, simultaneously running, it took around 45 minutes for installation of two service profiles. So let's see what's happening on the KVM consoles. You find that the first one is running the post install, but the second one is still running. So after the pause, let me check, log into one of the servers here. Okay, the network interfaces are properly configured. The second one is booting up now. So let's understand a little bit more about the boot details here. So in the HTTP server partition, I pre-created these image files with the names as service profile names. And these are pre-created by reading a text file, which has all the network information. If you mount the images, what you will find is they have just the kickstart file. So the kickstart file has the network information for the boot and any other network IP information for the interfaces and any customization and packages for the SDS install. With that said, let me log into one of the servers. I pre-created a script to check the connectivity between all the booted nodes as part of my boot process. So this will validate the SSH trust on different networks that are needed for SDS across all the nodes. So analyzing the timelines, we find that the most of the time is spent in discovery of the hardware, associating the service profiles, and then installing the OS. The process took for around 55 minutes, but these were run in parallel and will probably add very little more time for more parts. Okay. With that said, thank you very much for watching this video. I am also working to integrate few SDS applications to the mix. This will give an end-to-end installation for a customer to automatically deploy the software-defined storage. And thanks once again for watching this video. Thank you.